Hello, welcome again. This is my second circuit using Pic16F84A microcontroller. So you can see from the diagram, this is a simple one loop alarm, very simple, and with a simple code you can improve it, you can adjust it, you can maybe work it out to suit your needs. But first of all, as usual, we go to our text. Electronic waste benefit. This is our philosophy. We use as much waste as possible. And remember, please, electricity can kill. You must be experienced, or you must be able to be working with someone who has experience, a mentor, or you should have prior electronics knowledge, because this is not a lesson on electronics, it's a share on function description of the circuits that I've done. I would want to share with you, and please, I also expect that these circuits will best suit people who are 10 years and beyond, no younger. So please note, as I have always been talking about, we are not going to learn electronics much here. It's just a circuit description of the circuits that I've done, the gadgets that I have created, some of them, and they work. That I can guarantee, unless if there's a mistake, I'll be happy to share with you from your feedback. The philosophy of this one is, please use as much recycled material as possible. You can get PIC microcontrollers from used equipment. Take out the PIC that would best suit you, and you can reprogram it, you will reuse it, and actually it will benefit. You can use this as a training aid. You can use it to learn the PICs. You can use it at home. You can use it as an industrial product. The resources required, as usual, simple, straightforward. But on this one, you need a computer, basic for programming the PIC. You can use a PIC kit, which is USB based, or you can have a computer with a serial port, a 9-pin port. The programmers, you can actually build them yourself. There is the JDM, which is I've been using. I've also shared with you here. I'll show you how you can build your JDM programmer. Quite good programmer, it works. But you can also buy the PIC version 2 or PIC version 3. Power supply you will need for the PIC programmer to burn your code into the PIC. Then please recycle components as much as possible. Like I have said, not meters, not pretty much, but you need, of course, you need a multimeter, you need electronic tools, the cutters, the screwdrivers, and all that. Anything, a workshop kind, or you can borrow from someone, or you can go to a workshop where you can actually have these tools. The oscilloscope, not much, don't need it that much. Logic analyzer, if you have them, of course, you can still use them. The softwares, please download from the internet, they are there. The PIC for this circuit, you will need it. Proteus for simulation, you may need it, or you can get the free versions that are there on the net. You can download the trial versions and use them, no problem. And this one, please, it's not using this software, the LD Micro, which is available free on the net. It's using flow code from Matrix. You can download the free version. There is a free version for it, for learning, but not for production. And why I use these two programming tools is because I am not a C programmer, I'm not a programmer, but I can program using graphical methods. I can do programming using graphical methods. I cannot program in C, neither can I program basic or I'm not a programmer. I'm a hardware person, I'm not a software person, but this, it works. I've done it, I've used it. I'll show you on the simulation as well, but it's a practical circuit that works. So this will require you, your time, your patience, your passion, your dedication, yourself. Thank you very much for taking your time. I hope you enjoy as much as I would enjoy myself. So what is the story with this alarm? It's simple, and I hope it's going to be a short clip. What it does is it checks the sensor, which is a loop, one continuous loop. If it's broken, the alarm will actually time out and sound a siren. The sensor can be a magnetic sensor, can be a motion sensor, as long as it can break the circuit on this input pin. Remember, please, alarms are break circuits. Alarms are break circuits because everything tends to break. You do not make sensors as make circuits, because if you make a make circuit, if it fails to make, then you are in problems. So alarm circuits, especially sensors, are actually break circuits. Even if you look at the key, the security key switch, it must also be a break circuit. Break to activate, make to deactivate. You would rather have it difficult to deactivate rather than difficult to activate. So it must be a break circuit. In this state where it is shown, it is actually deactivated. So you have two circuit sensors, and this is the panic button, which is straight on, alarm on condition. So you have two inputs. So well, I would say two loops, not one, of course, but the other one is normally just provision for panic. It's not really a loop for sensors. It's actually a switch that you activate. Press in, it sounds, although sometimes you can use it as a sensor on the door or whatever, a critical door. It says if you just open it, alarm goes on. So what does it have? Those two inputs, the key switch, security key switch here, and then the outputs. You have a siren output, which is indicated here as an LED, and then the armed indicator, which is also an LED. But here the siren output, please wire it with a transistor or a relay to activate a siren. You can't power anything using an output of a microcontroller. Please, this is your homework. Use a relay if you are going to build a practical circuit, because this is a simulation circuit. When you're building a practical circuit, you put a ULN 20034 whatever, a transistor driver for a relay, or a MOSFET for driving a siren. But best, use a transistor driver. Then this one you can use an LED, no problem, but maybe even through a transistor driver is okay, because this is just indication that the alarm is in active position or it's armed. Then there is a beeper. The beeper, the story with the beeper is this alarm is actually, when you activate it, you can activate it whilst you are inside the room or the house. It gives you 10 seconds to go out before it actually reports a violation. So it gives you, which is adjustable. You can adjust that, and the number of seconds, the time that you can actually move out. So when you are going out, it gives you activate by breaking this loop, and then it actually goes into armed position. When you are coming back, you open. So coming back is always violation. You violate, the alarm system, but it gives you some seconds before it sounds in a siren. So that's when the beeper comes in. It starts to sound. This is a beeper. Please wire it as well through a driver. This is not a frequency. This is a DC beeper. So we are using a DC beeper or sounder that alarms, that sounds, that gives you a signal that the alarm is violated, and then the siren comes on after some seconds. So this is how it works. And remember, here it's actually a break circuit. This one is a break circuit, that one is a break circuit, that one is a break circuit. So the inputs are actually a high, and whilst it is in a steady state, a low here denotes, tells the microcontroller that, well, everything is okay. If you break here, then a high as an input is a violation, and then the program will actually latch and actually send a condition of alarm condition. The beeper comes on, the siren will come on after some seconds. So this is how it works, and here is the program for it, written in flow code version 7. You can download it and use the free version, and this PIC is actually on the free version, 16F84A. The limitation is on number of PICs you can use, and also the number of these blocks that you can use. For the version 7, you can use up to 20. The previous version number 5 that I was using, you can only use up to 16 blocks of these ones. So this is the program in graphical mode. You have your output, reset output, or output to 0, and then output A is just an indication that there is the system is active. You can update the diagram if you want. Port A is true. So on port A you have an output of 1. It comes high. Maybe you can actually see on the simulation. Delay is 15 seconds, and then the output goes to output armed. So what is happening is, if it is not reset, if the PIC is not reset, this program is running. So our key, our security key, is actually resetting the PIC, and then if you remove the reset condition, the program runs. So it just delays 15 seconds. So this is the time for you to go out. You activate the program to run by removing the reset condition, then the program starts to run, times 15 seconds for you to go out. Then it shows you after 15 seconds the alarm is armed. And then these are the sensors, input sensor, and then the input panic, and then it comes to a decision making here. If the panic is actually activated, if it's activated, it goes straight to the alarm condition. If it's not, then it checks again, if the sensor is okay. If it's not, then it starts again to program point A here, and then if it's violated, then the beeper sounds here. The output of the beeper delay sounder. It delays for 10 seconds. This is the entry time now, 10 seconds. When you're coming back, you can enter, you can violate and delay 10 seconds, after which the output beeper goes off, and then now the siren starts, and then delays for 5 seconds. Now this is only for simulation, otherwise here is the timer for the siren to go on, off, on, off. Here you can put minutes. It sounds on, delays maybe 10 minutes, or delays 30 minutes whilst the siren is on, and then it goes off. You see this output and that output, it goes to 0. So siren goes off and delays for some seconds, starts again, goes to B, starts again. So this is on off until you come and reset the Pic or deactivate the alarm. And please, this share is not about how to use the flow code system. There is enough information on the net. You can download and learn how to use flow code, how to program this one. This is just, I wanted to show you where the program is and how I did it. I was limited by the number of blocks that I can use because it's the free version. So this is effective enough. Now going back on the simulation of that, here is the simulation of that circuit. You load the X file here. The X file, you find it on the folder that I've shared with you on the alarm folder. There's the X file. You load here. Again, this is not a tutorial on how to use Proteus. You can download. You can use any simulation software you want, but the X file I've provided. Also on the flow code, you can actually produce the X file. You can actually, if you see, you can actually here compile to X, or you can compile to C if you want to C and modify and rewrite and learn how to write C. Well, I'm not a programmer, I'm not interested in C, I'm interested in just getting my X file, which I would pen into the Pic. So here's the simulation. I'll use my X file, which is in my folder. This is the folder. I load it here. I correlate my frequency with the frequency that I have programmed in the flow code platform to 4 megahertz, because I've programmed my Pic to run on 4 megahertz. So here I program it to run on 4 megahertz. The 84A, I doubt if it has an internal oscillator. I think not. So you need an external oscillator with RC or crystal. You can choose what you want. Learn about how to do Pic hard wiring. So here's my X file loaded into the Pic, and then that program will actually run will run this circuit. So if I start my simulation, right? Okay, right, just start my simulation. Right, now the simulation is running now. You see here the key is in the deactivated position because it's on. If I open it, the Pic will start to run. Okay, check how the Pic is responding on the output, especially RAO, which comes on. RAO comes on here, so you can use that output as an indication that the system is on. And then now check what happens if I am going out. Press this one. This is a security key which you can use the electronic lock, like I said, to break this circuit so that the Pic starts to running or the program starts to run. And then if I'll go out, and then now I'm coming back. If I come back, I violate here and check here, the beeper is running. It's on. It gives me, remember, 10 seconds, which will be different from the computer timing. Now the alarm sounds. If I come here and do this, deactivate the alarm. So activate. It gives me 15 seconds to go out. Before that, I can actually violate it because nothing happens, because it's not in armed position. As long as this one turns blue, any violation will activate the alarm. So it waits for me to get to 15 seconds, which yeah, now it's active. If I see the yellow comes on, the beeper gives me the time. If I come and deactivate here, no alarm. So it gives me 10 seconds to deactivate the alarm. Right, now the panic button. The panic button is a straightforward. Now there is the panic button, but because the alarm is not armed yet, the panic button will not respond. So wait for the system to be armed, 15 seconds plus minus, so the timing is not proper, but in the real world it will actually show the real time. For simulation, you can change the timing. Right now the thing, the alarm is armed. If I go press the panic button, the alarm straight on sound. You can check here that even if I do this, there's no change. As well as on the sensor, if I open close, nothing will change until I do this. Right, so now armed, and I would want to show you the on-off system, the on-off timing. This is done usually to save the siren from continuously running, because to burn out you need to make it rest. It depends on the duty cycle of the siren. So it's on here, it's short, but normally in real time it's actually a bit long. So for simulation purposes, I've made the on-off time very short. Now if I close here, you see nothing is changing. The beeper is still on, and the alarm will sound as long as I did not deactivate it. See, nothing happens. So whatever happens to the input to sensor is immaterial anymore, because the alarm has been violated. So it goes on for some seconds. I've made it, I think 5. It goes off, goes on, goes off. So the on time must be longer than the off time. This is too short for simulation purposes. Otherwise you should make it in minutes. I've shown you where you can change the time on the flow code program. You can change it. It's there. It's shared on the folder. So until I come and do this, it will continue running on off, and then reset. This is a security key. This is normally hidden, or it's actually a keypad with a code that you must enter, or remote controlled, written somewhere. This is the security part. In all these are security parts. The indication, okay, people can see. You can actually put an indication, because normally you would not want someone to break in and then later on realize, oh, there is alarm. So make it visible that there is an alarm system. You can make this one flash. You can add some circuits to make this armed flash, or something like that, to just warn off those who would want just to try. Right, so now this is what the circuit is all about. Just simple, straightforward. The PIC programming is simple also. It uses what is called in-circuit serial programming. Just a few wires to program it. You can program it on breadboard. You can program it maybe just straight wiring. You can program it. It's simple. It's a simple programming method. That's what I like most about PICs. So we stop our program, and I would actually want to show you how the circuit that I've used to program these PICs, my JDM. Sorry, excuse me. So this is the JDM programmer using a serial port. The old computers, old laptops. These days there's only USB. So you must actually now make your, if you would want to make your own USB PIC programmer, which is a PIC kit. It's provided for free, especially the PIC kit version 3. But this one is a JDM, which uses the serial port. Notice that on this JDM programmer, normally what you get on the net, the JDM programmer is powered through the serial port, but nowadays you can't. I've tried the ones with which are powered through the serial port. They don't work. I've actually redone this to power the programmer from an external power supply. I mixed some 2 circuits that I found, and then now I could actually program my Pics. So here is your 15 volts input, 18 volts. This IC can take up to 32 volts and 35 volts depending on the 78128 that you get. So I prefer that you put maybe 15 to 18 volts here, and then here you clamp this voltage to 12 volts plus 1.2 here is 13.2. This is to create the what is called the VPP voltage, which is normally high for most Pics. So this is the JDM. So find the JDM programmers on the net and learn about them, and you can build it. If you make this one, I'm sure it will work for you. Please keep the cables as short as possible. If you make them long, sometimes you find your programmer not working very well. How it is made and why this diode, well, I think maybe not, it's out of scope of this share, but this one has worked for me very well. Here's a 5 volt supply. You can actually program a Pic without even the crystal oscillator and all that. So you find you only need 1, 2, 3, 4, 5 wires to the Pic to program it. That's all. So this I called the powered JDM Pic programmer, Pic Proma, well, short for programmer. So this is my JDM programmer. Works very well, nice and straightforward. And yeah, that's all about this alarm. Flow code, remember, graphical programming. Here you can change your delay out time. You can change here, because if you double click it, you can change your time here. Also here the on off time you can change here. I've made these ones only for the simulation, so you can change here seconds, how many seconds you want. So this is the one, and then you can compile it. When you compile it, remember it outputs in number of files. The only files that you are interested in is the X file. That is the file that you put into the Pic, you burn it to the Pic. And here please choose the correct Pic. Choose the correct Pic here and configure it to the settings that are required. The most important is the frequency and whether it's internal or external. And then the other things is memory locking and all that. Sometimes the defaults are okay. Well, I think that's more about it. And you can actually simulate this circuit here on the flow code as well, using these switches, and go on simulation. Here is the button for simulation, but since we are not learning about the flow code, I leave it to you. I'll give you this code. It's there on the share file. Yeah, I think that's all about. Thank you very much, and I'll be glad to hear from you. Your feedback. Please, I'll take time to respond because of other things. I'm doing many other things. This is my email where you can provide the feedback, and I'll share this circuit on Google Docs. Thank you very well. Enjoy, and please feedback. Thank you very much. Good day.